Hi, in this video we continue our discussion on the topic division with remainder. Find the quotient and remainder when 4096 is divided by 7. Write an equation that expresses the relationship between the dividend, divisor, quotient and remainder. So recall that 4096 is the dividend, 7 is the divisor. When we carry out this procedure of division with remainder, this is what we do. We look for the maximum number of multiples of 7 in 4096 and we record our findings in this manner. We write 4096 equals the maximum number of multiples of 7, so that number times 7, and if that many copies of 7 doesn't quite get you up to 4096, how many of numbers you're away from 4096 gets recorded here as the remainder. So let's try to find the quotient and remainder on the other board. So 4096 divided by 7, and we would like an equation of this type. 4096 equals maximum number of 7 copies of 7 that are in 4096, and then a remainder, another whole number here. And recall this whole number could be any number from 0, 1, 2, 3, 4, 5, 6. It could not be 7, because if it were 7, then you could increase this multiple one more time. So let's go ahead and start counting the number of multiples of 7 in 4096. So let us take a wild guess and see if there are any 4-digit multiples of 7 in 4096. The smallest 4-digit number is 1000, and we already see 1000 times 7 is 7000, and if you do that, we go over 4096. So no, there are no 4-digit multiples of 7 present in 4096. So next is to look at 3-digit multiples of 7. So let's do that now. So the smallest 3-digit number is 100. 100, and we do a mental calculation. 100 times 7 is 700. Could we do another 100 multiples of 7? So in other words, what is 200 times 7? We can do a mental calculation. That is 1400. We have not gone over this number. So can we now look at 300 multiples of 7? So do those mental calculations until you arrive at 500 times 7, which is 3500. Notice that if you had done 600 times 7, you would have gotten 4200, and you would be going over 4096. So you do not have 600 multiples of 7 in 4096. You do have 500 multiples, because 3500 is still less than 4096. So you have 500, and you may have even more multiples of 7 in this number. For that we need to do a calculation. So we do a quick calculation here. 4096 minus 3500. We've already, using 500 multiples of 7, we've already gone up to 3500 on the number line. And now we are seeing how many more numbers are there between 3500 and 4096. So a quick calculation shows you that is 596. You can do the subtraction carefully. So now we ask ourselves, in 596, how many 2-digit multiples of 7 exist? So you can start with the first 2-digit multiple, 10, and do a mental calculation. 10 times 7 is 70. Well, we have 596. So we could do 20 times 7, 30 times 7, and continue that until you convince yourself. So this gives you 560. If you were to do 90 times 7, you would be going over 596. So what this is saying is, if you were to do 500 multiples of 7, you would get up to 3500. After that, if you do 80 more multiples of 7, you get up to 560 more, and you still won't be reaching for 4096. you will be at the following number. So we do another subtraction. So we get 36. So now we have 36 numbers. We have not yet gone up to 4096. We are 36 numbers less than 4096. And remember, we are trying to count the multiples of 7 in 4096. So now let's look at single digit multiples of 7 in 36. So for that, it's very easy now to see 5 times 7 is 35. If you were to do 6 times 7, then you would get 42 going over the 36. So as far as single digit multiples of 7 go, we have 5. So we do that, we write 35 here, and now we have a remainder of 1. So let's go back to the original question. This is the dividend, this is the divisor. When we do division with remainder, we're asking ourselves, what is the maximum number of multiples of 7 in 4096? Our calculations show us we could have 500 plus 80 plus 5 multiples of 7. So that is 585 multiples of 7. That would get you up to 1 less, this remainder of 1 less than 4096. So the remainder is 1. So let's record that on the other board for our answer. So here we have 585 plus 1. The quotient is 585, 1 is the remainder. And so this procedure that we have done is called division with remainder, and we'll do some more examples. We'll end this series with the long division algorithm. Thank you.